Hello everyone, we are from Group 8. In this video, we are going to talk about our mini project in Applied Thermodynamics, which focuses on the topic of steam engines. Before we start our presentation, let me introduce my team members from Group 8. From the left, the first one is me, Theodora Veratomi, followed by Melvin Francis, Nur Hafiza binti Lokman, Nur Muhammad Syafiq bin Muhammad Kasim, Dayang Nur Syafika Nabila binti Nordin. First of all, a steam engine is a heat engine that performs mechanical work using steam as its working fluid. Constructing a DIY steam engine vehicle from recycled household materials to travel 100 cm is a practical exploration of applied thermodynamics. This project emphasizes the second law of thermodynamics, which focusing on heat transfer, energy conversion, and entropy generation. We use materials like aluminum cans, chopstick, and old mechanical components to promote sustainability. This process strengthens theoretical knowledge and supports innovative in engineering solutions that serve as a valuable teaching tool in thermodynamics.
Next, the steam engine is a type of heat engine that converts thermal energy from steam into mechanical work. This process operates on a principle of the Rankine cycle, a thermodynamic cycle that describes the conversion of heat into work through a phase change process involving a working fluid. The process begins in the boiler, where water is heated to produce high pressure steam. This steam is then flows through a turbine, causing it to spin then generate mechanical work.
The problem statement in this project is build a DIY steam engine. We have to explore thermodynamics and engineering principles through designing steam engine models. The significant output must align with cost outcome and PO3, which is design or development of solutions. Next, the objective of this project is build a DIY steam engine vehicle using recycled or reused household materials that could travel a distance of 100 cm. The steam engine should operate in accordance with the second law of thermodynamics, demonstrating principles of heat transfer, energy conversion, and entropy generation.
The steam engine starts with a boiler where water is heated and converted into high pressure, high temperature steam. The boiler is typically fueled by burning coal, natural gas, or other combustible materials, providing the necessary heat to vaporize the water. Next, steam turbine. The high-pressure steam generated in the boiler is then directed into a steam turbine. The steam turbine is a mechanical device featuring a series of blades or vanes arranged around a central, rotating shaft. As the high-pressure steam flows through the turbine blades, the force of the steam causes the shaft to rotate. For mechanical power conversion, the rotating shaft of the steam turbine is connected to a generator or other mechanical load, such as a pump or a compressor. The rotation of the turbine shaft converts the thermal energy of the steam into useful mechanical power, which can be used to perform various tasks. Last but not least, condensation and recycling. After passing through the turbine, the steam is directed into a condenser, where it is cooled and converted back into liquid water. The condensed water can then be recycled and sent back to the boiler, completing the steam cycle and allowing the process to repeat.
My name is Melvin Francis and I will start the presentation by presenting the component and material that our group used in building a steam car. First of all, we have plywood for tire. Next, we have chopsticks for the steam car body. Next, my group also use aluminum can for the boiler part and the aluminum cap for the tire part. Next, we also use rubber to that we stick at our steam car tire to increase the frictional force. My group also use aluminum foil to wrap our steam car to increase the heat resistance. Next, rivet also include in our group component and material that used to be as a nozzle for our steam car. For heat source, my group use the gas torch. My group also use an epoxy and second glue. For cutting part, my group use scissors and cutter.
Hi, I'm Nur Muhammad Shafiq bin Muhammad Kasim. My metric number is BK20110343. I would like to continue with my part, which is pre-modeling sketch, post-modeling sketch, and I would like to explain on how our steam engine works. We will start with pre-modeling sketch. We plan to design our car as flat as possible so our car can move easily. Due to this strategy, we heat the boiler outside the engine instead of including it inside the system. Additionally, we also plan to apply a forward wheel drive system or FWD to create a pulling effect in the car. This is due to pulling create less friction than force. In terms of designing the steam engine, we design it using Onshape as it is the most simplest and easiest software to do modeling. As you can see, this is our pre-modeling sketch that consists of left side of view, front side of view, back side of view, right side of view, and isometric view. Move to the next part. This is our post-modeling sketch that consists of turbine, nozzle, boiler, front wheels, back wheels, and butane gas. I would like to add an information about the nozzle where the diameter of it is around 0.5 mm. This is very crucial to produce a high pressure of steam. I'm not going to add the others as they are already mentioned at component and material part. Moving to my last part, I will explain to you on how our steam engine works. As you can see, there are numbers that indicate the flow of the process. We will start with number 1. We use gas torch to boil the water until it boils. A high pressure of steam is produced during the process occur. Then it shoots out and spins the turbine wheel really fast. The spinning turbine makes the car's wheels turn, and now the car can accelerate. Video in the next slide will show the demonstration of our car. That's all for me. Thank you.
Deja vu, I just been in this place before. Higher on the street, and I know it's my time to go.
Next, let's move on into the calculation for question 1, which is to determine the heat input required to generate steam. So for this calculation, we use formula Q in equal to enthalpy steam minus enthalpy for water. Q in equal to H3 minus H2, which is the set of water in H3 is in gas and set of water in H2 is fluid. So by referring the table F4 at temperature of 100 degree, the enthalpy gas is equal to 2675.6 kg over kg, while enthalpy for fluid is 490.4 kj over kg. So we substitute the value into the formula and we will get 2675.6 minus 490.17, and we will get 2256.43. But we want the answer in kj, so we times the value with the mass of water that our group used for in the boiler, which is 0.17 kg. So our group get the heat input required to generate steams is 383.59 kg. Now for the question 2, which is to calculate the work output of steam engine, we use formula work output equal to H4 minus H3. For H3 state is fluid, and we already got the enthalpy for fluid, which is 2675.6. So from table A4, at 27 degrees Celsius, which is the room temperature, we don't have the exact value for 27 degrees Celsius. So we need to use the interpolation formula, and we will get H4 equal to 2550.14 kJK over kg. Now we substitute the value in the formula, and we will get 2675.6 minus 2550.14 kJ over kg, and we will get 125.46 kJ over kg. But we want the value in kj, so that means we need to times with the mass of water that we use in our boiler, and we will get work output equal to 21.33 kJ. Now for the last question, which is the efficiency of steam engine. First of all, we use formula W in equal to H2 minus H1. From table A4, at temperature 100 degree H2, we take the enthalpy fluid, and we will get 490 and 1.7 kJ over kg. From table F4, at temperature 27 degrees Celsius, we don't have the exact value for this temperature, so we do interpolation, and we will get the H1 value equal to 113.194 kg over kg. We substitute the value into formula, and we will get the work in equal to 305.976 kg over kg. But we want in kg, so we times with the mass of water, and we will get the value of 52.02 kilojoule. Now to calculate the efficiency, the formula is work net over Q in. To find work net, we need to subtract. To find work net, we do 52.02 kilojoule minus 21.33 kilojoule over 383.59 kilojoule, and we will get the efficiency of steam engine 0.08 or equal to 8%. Now for safety precaution, let's go through one by one. We start from steam pressure and boiler safety. First, we need to ensure the steam boiler is working well and the pressure release valve function correctly. Never exceed the recommended operating pressure. Next, let the boiler cool completely before maintenance or inspection. And we need to regularly check the boiler and steam carrying part for wear or damage. Now, for the burn hazard, the steam end part can get very hot and cause burn. Avoid touching the hot surface like boiler, steam pipe, and engine part. Next, we need to use heat resistant glove and safety gear when handling the steam car. Last but not least, stay at safe distance while the car is running to avoid accidental burns. Last but not least, for the fire safety, we need to keep a fire extinguisher nearby in the event of a fuel or steam fire. Next, avoid running the steam vehicle in the location with high fire dangers such as dry and frosted terrain.
We encountered several challenges during this project. First and foremost, low steam pressure. The initial nozzle diameter was too large, resulting in low steam pressure. To solve it, we reduced the inner diameter of the nozzle to increase the steam pressure produced. Secondly, inefficient heat source. The fuel tablet we used initially took too long to heat the water. So, we switched to a braising torch to provide more efficient heating. Next, heat resistance issues. The glue used for the turbine blades melted due to the high steam temperature. So we use epoxy glue for better heat resistance. Last but not least, high tire friction. The friction between the tires and the gear connected to the turbine was too high, so we reduced the number of rubber bands on the tires. Our project involved building a DIY steam engine vehicle using recycled household materials. This practical exploration emphasized the second law of thermodynamics, focusing on heat transfer, energy conversion, and entropy generation. By constructing the engine using materials like aluminum cans, chopsticks, and old mechanical components, we promoted sustainability while reinforcing our theoretical knowledge. The calculated efficiency of the steam engine model achieved was at 20.9%, which is quite low, primarily due to heat losses to the surrounding. Other errors and precautions were identified and addressed to minimize the percentage errors and improve the accuracy of the experimental results.
For future recommendation, the first one is to improve the engine design. Research and implement more efficient steam engine design to increase the power output and efficiency of the vehicle. Second, explore new recycled materials, which continuously look for innovative recycled materials that can enhance the efficiency and sustainability of the project. Third, use high quality materials. Invest in high quality materials to improve durability and performance.
In conclusion, constructing a DIY steam engine vehicle from recycled materials has been a valuable educational experience. It allowed us to apply theoretical concepts of thermodynamics in a practical setting, promoting both sustainability and innovative problem solving. With an efficiency of 20.9%, our steam engine model demonstrated a practical challenges and potential for such designs. This project not only reinforced our understanding of heat transfer, energy conversion, and entropy, but also highlighted the importance of sustainable engineering practice. Thank you.